You're warm right now. You're not thinking about it. The room is somewhere near 20 degrees. Your body sits near 37, and the gap between those two numbers is so comfortable you have never once had to notice it. Warmth is the thing you assume. The air readout is almost boring today. Carbon dioxide, around 420 parts per million. Oxygen, 21%. For the first time in this series, none of that is the problem. The air where you are going is breathable. Your blood will saturate. Your lungs will not complain. The number to watch is not in the air, it is the temperature, and it is falling. 34 million years ago, the end of the Eocene. For tens of millions of years, the Earth has been a hothouse. No permanent ice anywhere. Palm trees near the poles, crocodile relatives in the Arctic, a warm, wet, green world that has forgotten what ice is. That world is about to end, not in a day, not in a catastrophe. Slowly, and for a reason almost too quiet to notice, you are standing on a coast that will one day be Antarctica. It is cold, not lethal, not yet the cold of a raw morning on a northern shore. Behind you, a forest. Southern beach, ferns, the last green edge of the Eocene, and it is dying at the margins, thinning where the frost now reaches it. In front of you, something that has not existed on this continent for tens of millions of years. Ice. Not a cap, not yet a mile-thick sheet. An edge. A pale front of new glaciers grinding down toward a coastline that, a geological moment ago, was very nearly subtropical. You are watching an ice sheet being born. It is the first one this planet has grown in roughly 40 million years, and once it forms, it will not fully melt again for as long as there have been mammals worth the name. Listen. There is almost no sound. A little wind. The distant crack of ice under its own weight. This is the quietest catastrophe in Earth's history, and it is a catastrophe only for the warm world that is ending. Take a breath. Nothing happens. That is the point. This is the first place in this series where the air is simply fine. Oxygen sits at 21%, exactly what you left. Carbon dioxide is somewhere around 700 parts per million, higher than your world, but the lowest it has been in tens of millions of years, and nowhere near enough to cloud your thinking. No headache, no breathlessness, no slow fog behind the eyes. Chemically, you could live here. So why are you already shivering? Because the whole story of this place is temperature. Your body loses heat to cold air, to wind, to the ground through your feet. On this coast, with no shelter and the wrong clothes, you have perhaps a few hours before that loss outruns what your body can make. The threat is real. It is just not in the air. It is in the gap between your skin and everything around it, and that gap is widening by the century. So what turned the hothouse off? Not an eruption, not an impact. Mountains. Around 50 million years before this moment, India collided with Asia, and the Himalayas began to rise. Fresh rock, pushed high and exposed to rain. And here is the quiet machinery. When rainwater, faintly acidic with dissolved CO2, falls on silicate rock, it reacts. It pulls carbon dioxide out of the air, binds it into dissolved minerals, and rivers carry it to the sea, where it is locked away as carbonate on the ocean floor. Every raindrop on every exposed Himalayan slope removes a trace of CO2 from the sky. Multiply that by mountain rains, by monsoon rains, by 50 million years. In the 1980s and 90s, the geologists Maureen Ramo and William Ruderman argued that this uplift and weathering acted as a planetary thermostat, that raising the Himalayas slowly bled carbon dioxide out of the atmosphere. It is one of the longest cooling events in Earth's history, and it has no villain. Only rock, rain, and time. Then a second lever. To the south, the Drake Passage, the gap between South America and Antarctica, finally opened. Ocean could now flow all the way around the pole unbroken. The oceanographer, James Kennett, proposed that this new Antarctic circumpolar current walled the continent off from the warm water drifting down from the tropics and left it to freeze in its own cold, and there was a threshold. The climate modelers Robert DeCanto and David Pollard showed that Antarctic ice does not creep in gradually. It waits, then arrives almost all at once. When CO2 fell through roughly 760 parts per million, the tipping point was crossed. Ice that could not form the century before became ice that would not leave for 34 million years. We can read the moment in the seafloor itself. Working from the chemistry of tiny shells buried in deep-sea mud, the geologist James Zakos and his colleagues traced the temperature of the whole ocean across this boundary, and the record shows not a gentle slope, but a sudden step down, a fingerprint the ice left as it locked into place. Geologists call that step Oi-1, the first great glaciation of the modern world. The mountains drew down the warmth. The current locked the cold in place. You are standing at the exact moment the two finally agreed. Turn back to the dying forest for a moment. The animals here are not strange. That is what is strange about them. This is a world of recognizable mammals, early relatives of horses, rhinos, deer, dogs. The Great Reset after the dinosaurs is long over, and mammals have inherited the earth. But the cooling is rewriting the rules. The warm, dense Eocene jungles are breaking up into open woodland, and soon grassland. Bodies built for warm forests are running out of forest. The turnover is sharp enough that paleontologists gave the extinction pulse in Europe its own name, the Grande Coupure, the Great Cut, as archaic warm world mammals gave way to hardier, cold, tolerant kinds moving in. Cold opens a door. A world with ice, open ground, and sharp seasons rewards animals that can range, migrate, insulate, store fat. It is a niche that did not exist in the hothouse. And far down that same long road, through grasslands, through ice ages still tens of millions of years away, sits a cold, adapted, wide-ranging mammal that will one day stand on this coast and ask what it would feel like. Here is the honest answer. At these latitudes, on this coast, unprepared, you are in trouble within hours. Not from the air, from heat loss, shivering first, then clumsiness, then the creeping confusion of a falling core temperature. The cold does slowly what the Cambrian and the Permian did with poison and heat. But move north. This is the crucial difference. Away from the pole, the Oligocene is not a killer. It is cool, dry, and seasonal. A temperate world, harsher than the hothouse it replaced, but one a prepared human body could live in comfortably. There are days you would call pleasant. So the verdict splits by geography. On the Antarctic coast, watching the ice arrive, survivable only briefly and only with shelter. Everywhere warmer, this is the most livable world you have visited. The atmosphere is safe. The seasons are familiar. For the first time, the deep past feels almost like home. The world did not cool because something broke it. No eruption, no impact, no poison sea. Just mountains rising a few millimeters a year, rain falling on bare rock, and carbon dioxide leaving the sky one raindrop at a time for 50 million years. The Himalayas are a carbon sink that switched on long before there were humans to notice, and it is still running today. Without it, the Eocene hothouse might never have ended. With it, an ice world arrived, open ground appeared, and a niche opened for the kind of animal that could survive a cold, changing planet. We are that animal. The warmth you take for granted exists inside a world. These silent mountains spent 50 million years cooling down. You are warm right now. Now you know how rare and how recently arranged that warmth actually is.